Hi guys, this is Monit. I will be solving the MYP assessment in this series, question by question. So if you wish to have all the resources with criteria-wise questions from all the topics of the MYP Physics, you can check the link is there in the description. You will get all the details of the syllabus with the explanation and with the worksheets and a bonus for you to solve a past year papers with all the details with the marking scheme. Wish you all the very best for your e-assessment. Enjoy the video.
Okay, guys, so this is question number two. An alternative to coal-fired power station are nuclear power plants. The primary fuel for most of the nuclear power plant is the isotope of uranium-235. So the question A part for this is use the periodic table as it was there in my previous video also I shared you. State the number of protons and the number of neutrons present in the nucleus of one atom of uranium-235. So if you just go here and click on the uranium, which is this here. So you can see the atomic number is written here 92 and the relative atomic mass is 238. Okay. So the question is asking for the uranium 235. Be very careful about this. So atomic number remains the same. That is the number of protons. So we will just write down the 92 and the number of neutrons is nothing but the difference between the mass number and the atomic number. So they are asking for 235. So you can simply say that 235 minus 92 will be your neutron number. So I will just write 143. So that is the answer for the question number 2A part. Now just look at this and try to answer. I will just play. There is no audio in this. It is of 2 mark question. Okay, so look here. Outline how the protons and neutrons are affected by the fission of uranium-235. So you might have seen in the animation, okay? So I can just write it down. Yeah. So protons and neutrons are divided between the daughter nuclei such that the total number of neutrons and protons is the same after the reaction as in the case of uranium-235. So we know that the total number of protons and the neutrons on the right-hand side and the left-hand side of your equation remains the same. So that's the answer. Now just pause the video and solve question number 2C. Okay. So suggest the meaning of the term chain reaction. So what do we mean by chain reaction? Okay, so I've written a chain reaction is a process where neutrons released during a nuclear fission reaction cause further fission reaction in the another uranium-235 nuclei, which leads to a self-sustaining series of reaction producing more energy and neutrons, which will continue further depending upon your uranium fuel which is present in the nuclear reactor. Okay, so this is your 2 mark answer for question number 2C. Now, question number 2D for 3 marks, just read the question. Okay, so we have to describe a possible danger of an uncontrolled chain reaction in a nuclear power plant. So just let me write it down and then I will explain to you. Okay, so if you look here, an uncontrolled chain reaction means that there will be too much energy which will be rapidly released during the reaction. So each fission reaction produces more neutron triggering the next further reactions. This excessive energy can considered as an atomic explosion if it is not controlled in a certain way, leading to the emission of radioactive materials into the surrounding environment, which will further cause health-related problems to all the living organisms in the environment, and it can damage the environment as well. So the 3 marks are possibly to first to explain what is the uncontrolled chain reaction, how it happens, then the what will be the result of it, like it will be an atomic explosion, and what would be the effect of that to the surrounding environment or the living organism. So these are the 3 marks for this question. So I hope you have understood it. If you have any doubt related to any of the questions, you can just comment it below There is a link provided in the description where you can find all the details of the MYP physics syllabus, and you can have access to the worksheets, criteria-based topic-wise worksheets, and bonus past year paper questions. Okay. Okay, now look at this question. It's very simple. Just pause the video and solve. Okay. So you can just click on this to zoom in. So they are asking you the 75%. So this is at 100%. Then this is 50, that is the 50%. And then 75 will be the next half cycle, which is 25. So it will be somewhat here. And if you pay attention, it will almost will be the between 1,000 and 2,000. So this will be 1,500 millions of years. So you can say how many years it would be 75% of the remaining uranium. So 100, then 50, and then 25. So 75% of the uranium will decay in 1,500 millions of years, you can say. I just want to copy it in millions of years, or you can just write 1,500 millions of years. Okay, that will be the answer. Now the last question, question number 2F, just pause the video and solve. Okay, suggest why the long decay time of uranium-235 poses a significant challenge for the safe disposal of fuel rod. So yeah, basically this is one of the major question, like what are the challenges we are facing in order to have a safe disposal of the radioactive waste that we got from the nuclear power plant. So just let me write. Okay. So the long decay, as mentioned in the above graph, you can say 1,500 millions. It's a long time. So it makes disposable challenge as its radiation harms health and the environment. And additionally, the fuel rod needs to be stored safely and securely for a long time since it remains radioactive for an extended period of time. And that is making the disposable complex and requiring long-term containment solutions. So that is all for the question number 2. Okay, so if you have any doubt, just let me know in the comment. I will try my level best to explain you further. And please share this video to all your other classmates so that it reaches to the masses. That's the only purpose behind it. Wish you all the best. See you in the question number 3.